minutes, and I hope you have some good learnings and better understanding at end of this uh, session. So, so let me quickly walk you through like what we are going to uh, have as a session is to see OPCA, how we can use OPCA for real-time deterministic Ethernet networks. So I would not like to mention any other names. So you know the other protocols that are being used currently in the market. So we are going to see like how OPCA can be used in this way. So normally we are all familiar about how we can use OPCA as a client server communication. But today I will be showing like how we can use OPCA for the purpose of controlling IOs, motion control, and high speed networking with very good jitter performance, round trip time, and also how TSN is going to complement. Okay, so let me quickly check the number of participants. Yeah, okay. Yeah, hello for all the new participants who joined. So I'm going to start. So anyway, it's going to be recorded and so it's going to be pretty quick. And also you can ask your questions. Later, if we have time, I will try to answer, or else I will make a post which follows up this particular webinar. Okay. So today we are going to look at basics of OPCA plus TSN in 30 minutes. So you know what to expect in 30 minutes, and also this is for beginners. So if somebody is in advanced level, I insist you to direct message me on LinkedIn, and also you would have my mail ID by now, so we can discuss more in detail about these concepts. But I would recommend you to continue to watch this so that you understand what I am doing and what as a company we are doing. And then let us start with why. Why this presentation and where I'm coming from, and why do we believe that OPCA plus TSN is a solution. So Industry 4.0 is where the integration of digital technologies into manufacturing and production process. So IIoT involves connecting machines, device, and sensors that are all connected to each other and to the internet for real-time data connection, and also data analytics to make more informed business decisions, and automated and connected manufacturing facilities make them more efficient. I think all these four are marketing messages, or you would have heard this multiple times. But what is the real business use case behind it? So you might be a business owner, or if you are an engineer, if you want to understand, okay, now I have all these points checked out. So what are the business use cases? Would be like predictive maintenance, supply chain optimization, one piece per batch, just in time, pay per use model, and subscription models. So, for example, if you want to make industrial automation as a pay per use model, so you need to know for example, imagine that you are buying a robotic arm, and imagine if you have a feature that you can say like the number of times I'm going to stretch the arm and close the arm, or number of times I'm going to use the gripper. So that's the amount I'm going to pay. So for this kind of a solution or a business model, you need these devices to be connected to each other. They should be connected to the edge and also to the cloud. So this is what is important. And for these kind of business use cases, all devices must be connected with each other. So how OPCA is going to help us here, and how so why not the existing industrial Ethernet protocols? So the existing industrial Ethernet protocols are vendor dependent, lack of interoperability. For example, if you buy a PLC, and then also you have to buy your devices or motion devices or sensors from the same vendor. And then you need custom hardware development. For example, for real-time purposes, you need to have specific Ethernet interfaces, or specific cabling, or specific hubs that are linked to the same manufacturer. So, and also you need different protocols needed to hand over the data from sensor to the cloud, and then separate assets for IT and OT networks. So, which is clearly says that these these networks, we can see that IT and OT are not converged yet. So So why OPCA and TSN is important is because OPCA is vendor independent protocol, supports a range of transport layer protocols, including TCP, UDP, HTTPS, MQTT, and AMQP. So this particular point is the cornerstone of today's webinar, and we will be going in detail about how what is the capability of OPCA here. And coming to the third one, on the field level, determinism plays a critical role, and OPCA with standard Ethernet and TCP does not fulfill all the requirements. But OPCA, when integrated with TSN, it can offer low latency communication for real-time applications. And this is what we are going to see as a demo today. So TSN might be a new concept for few people here. So what I would suggest is, even if you know, I think this story would explain like how you can understand TSN in a easy way. So imagine in a meeting room there are 8 people, and then they are all talking with each other. And imagine that everybody needs or talking important information. So if all of them are talking at the same time, what happens is there is loss of information, there is confusion inside the meeting room. So what happens is that everybody are coming together, and then they decide that one person will be the grandmaster, and then we should all sync with his time that he has on his wristwatch. So what he does is this particular guy who's the grandmaster says that now my time is 4:10 p.m. Please adjust to it. So he says, so all the people who are ahead, they come back. All the people who are behind, they come in the front. So they continuously oscillate, they talk with each other, and now everybody are in sync with the grandmaster clock. And imagine the synchronization is in the level of nanosecond. Okay. So now that they have all the 8 people in the meeting room are having the same time, now it gives the capability. They decide that from 0 to 10 seconds, person 0 will talk, from the time 10 to 20 seconds, person 1 will talk, and it goes so on. So for every 80 seconds, one cycle repeats. So this is what happens. So the person 1 talks, 2 talks, 3, 4, 5, 6. So even if imagine that person 2 has a lot of information which spans for 30 seconds, he has to wait for 3 cycles to get his chance to talk, so that all the people inside the meeting room gets a chance, and then they are able to talk. So this we can compare with scheduled traffic, and this we can compare it with time synchronization. So now let us replace each person inside the meeting room with different traffic classes. And traffic classes in the sense, inside a factory floor there will be 8 types of traffic classes, which ranges from important motion control data, IO data, configuration data, service data, audio video maybe for a VoIP call, and also video for streaming. So all this will be available in the same network. So all of these people should be replaced with each traffic classes. So make this as a mental image. So now you can see that these are each traffic classes when there is no synchronization, which we saw in the earlier slide. There is a lot of confusion. You can see that everybody are talking together and there is a huge chaos. And here missing a audio video data, that's a VoIP call. Missing one frame is not going to kill anyone. But imagine in this chaos, if important motor control data or an important emergency switch that needs to be triggered is not done, then it would be a life-threatening incident. So this is where what happens when 802.1 QBV scheduled traffic is off. Now imagine you are switching it on, and then you can see each traffic gets its own slot to talk for the time that they need. So this is what is TSN. So now let us replace this particular traffic class to your motor control data. So now for demonstration purpose, we have split the bandwidth equally for all the types of traffic classes. So for us, the interesting data for in industrial automation or process automation, or even in automotive industry. So imagine airbag data should always be delivered on time, right? Or else people would die during the crash. So imagine your music system takes more bandwidth and your airbag data gets dropped, and that's a chaos, right? So we can allocate the bandwidth according to our application and design this particular QBV accordingly, which we will see it in a real-time demo soon. Okay, so now this helps us to say that OPCA along with TSN guarantees the delivery of packet on time and also with very good jitter, which we will be seeing in the upcoming slides. Okay, so here is an example possibilities of OPCA pops up plus TSN. You can see we are using a Linux B&R PLC, which sends the data to these robots. So you can see 300 bytes of data towards the robot is being sent, and this particular neuro robot receives it, and then it sends back the data to the APC so that all the numerical calculations for the robot path tracing is done here. So if you are interested about like how we have designed this particular robot path and how we designed it with OPCA, please do comment in the section, and I will share you the video of video which explains the entire design of this particular network here. And now comes the interesting part of this presentation. So imagine there are three values here in 32, U in 32, in 32 of a robot arm. So which we see. So let us compare it with this particular robot arm. And all we are very familiar. I think most of us would have this to control these values using OPCA client server communication and having a subscription enabled so that you could read the data always or write the data always. But this does not have a QoS that can guarantee the delivery of data. For imagine this particular robot arm needs a refresh rate of 250 microseconds. So obviously client server communication cannot cater these needs just because it's a connection based protocol and it's for its own reason in the own reason of its design. So for this purposes, these three variables can be sent over PubSub over raw Ethernet, and you can receive a cycle time of 250 microseconds. And for other purposes, like where you want to talk to two controllers. So imagine this particular controller says the robot to pick the defected boxes and allow the good boxes to pass through. So they need to talk with each other. So for this, we could use PubSub over UDP. So for this, the cycle time can be 1 millisecond. And again, instead of using PubSub over raw Ethernet, we could go for PubSub over UDP. And imagine this particular robot arm data should be pushed to the cloud. So this is something similar to what we discussed earlier. In the pay-per-use model, this particular robot manufacturer would need the number of times this particular robotic arm was used. Then they need to push this data to the cloud as well. But this particular data is not a real-time need for the for the robot vendor, right? So for this purposes, MQT PubSub over MQTT can be used, and the delivery of data is not a big problem. But there is one huge scenario that we need to consider is security. So since you are exposing your robot data to the cloud, and also obviously the person who's listening here can also control the robot, right? So for these purposes, you need a proper security mechanism implemented. So when we are using PubSub over MQTT, we could use security features like TLS, transport layer security, network layer security, and application layer security, which gives you the needed uh, edge level security where your factory floor remains secure and it can be protected uh, from all the threats that we are reading about. So all these comes under the concepts of OPCA FX, which I will be talking in the upcoming webinars. But today, let us uh, keep it with how we can use OPCA PubSub for real-time purposes. So so I'm skipping the first exercise because many of y'all would have known like how to control access a node using OPCA client server communication. And let me show you like what we are going to see today. So I have a camera that is placed here. So this is a B&R OPCA PubSub OPCA FX capable device. And this is our controller from TQ Systems. So this is going to send the data here, and it's going to control the IOs here. So I have connected the industrial LEDs to show it in this video. So right now this particular board is already running, but instead of connecting it to one of the ports here, I've connected it to another Linux box here, which runs our test suite, which will show what we are doing here. So let me bring up the test suite, which is part of our eTSN SDK. So you can see this orange line, which is taking the highest priority is the IO which is the IO data that is being sent from this particular box. So let me keep the screen side by side so that it would be easy for me to explain. So you could see that this particular TQ systems box is sending the IO signals to using the VLAN ID 3. So it's traffic class 3, and it is able to send with a jitter of plus or minus now for the past 5 minutes, it's plus or minus it's in the range of plus or minus 3 microseconds or 4 microseconds. So I think they went out of sync for some time. I think the synchronization would take more time. So that's why there is some packets that are spread over. But overall, I think the average is the jitter is at the range of plus or minus 4 microseconds. So what do you mean by jitter is, so imagine if the packet has to reach for every 1 millisecond, it either reaches at 1 millisecond plus 4 microseconds or 1 millisecond minus 4 microseconds and nothing beyond it. So this is real time, right? So if your application can live with it, and obviously this would be a very good solution for us. So you can see the other traffic classes are also prevailing, but they are not intruding inside this particular bandwidth that we have allocated. So from the bandwidth 250 to 500 microseconds, we have just allocated it for the real-time data that we are sending, and all the other traffic classes are available in the other windows that we have created. So this we can, let me go back to my presentation. So this we can compare it to the image that we are seeing here. So every traffic class is having equal bandwidth, but here you can see that from 250 microseconds to 500 microseconds, we have just allocated it for our real-time application. So we can be uh, uh, we can rely on this particular network, and the data delivery is guaranteed. Okay, so and also the jitter is plus or minus 4 microseconds, and this would say that OPCA PubSub over raw Ethernet is, so now you can see it is getting better because I started it. So it is even plus or minus 2 microseconds. So it's also in the nanosecond. So most of the packets are in nanosecond range and some are spilling out here. So this test suite proves that our OPCA packet is able to be delivered on time. And I have not yet, let me bring the camera image that I'm showing here. So you can see my hand here with my wedding ring, and my wedding ring is here. So I'm not. This is not a recorded one. Okay. So for this purpose, so now what I'm going to do is, so whatever you're seeing left side on the Grafana is running on this particular TQ system from the Up2 Pro board, which is I've logged in using this IP address. So this is part of our eTSN SDK. So now I'm going to remove the cable from here. You can see this. Okay. I don't want to disturb the network. So I just want to remove the cable from here. And you can see that the packets, I've removed the cable. So you can see they will be slowly lost. To see this, let me reduce the time. Uh, because the test suite is not receiving the packet anymore. So it's there for the last 5 minutes. Let me reduce the time slot to 1 minute so that we could see it immediately. So within some time, you can see that this packet is being lost. And I would like to put up the camera stream here, and I'm going to connect it uh, to this particular slot. You can see slowly, I've not yet connected. I just want to make sure that you are able to understand that I've removed it from the TQ systems. And then since there are no packets received, I think within few seconds, we will lose all of them. It's just 1 minute, last 1 minute. So we are able to do it. So quickly to recap, what we have done so far is we have seen that uh, we are able to understand that OPCA variables can be accessed by client-server communication, and also PubSub over raw Ethernet, PubSub over UDP, PubSub over MQTT for various purposes, like according to our QoS needs of the network. And we also saw an experiment that we are able to prove that, okay, now it's gone. So all the packets have gone because it's only last 1 minute. And now I'm going to connect this particular uh, Ethernet cable that comes from here. So you can see this white flat cable. The same white flat cable from the TQ systems is going to be connected peer to peer to this particular B&R bus coupler, which runs OPC FX, and I'm going to connect it here. So this particular LED that is blinking is the time synchronization. So it has settled down, and then it shows that it is in time sync. And then these are the LEDs here, and you can see that the LEDs are blinking in a ratio that so it is just a counter application that we have done, just a LED blinking application that we have done. And I have a GUI that is in front of me, but due to some technical difficulties, I could not share the screen here, but I'm going to increase the speed. Now you can see the LEDs are blinking in a faster rate, and I will make it much faster. Yeah, you can see literally it's so fast now, and I'm going to bring it back. So this is the overall application to show that we are able to send a packet for every 1 ms, and we are toggling these LEDs. And this particular board is running OPCA FX eTSN SDK, and this is from B&R Bernecker and Rainer. It's an Austrian-based company who have the support for OPCA FX for this particular IO module. And we are also having a Qt GUI that controls the speed of the LED. So right now, since I've completed this demo, I'm going to take a risk of moving this camera and quickly show the Qt GUI here. So this is the Qt GUI that I spoke about. So when I'm going to increase the speed, let me increase the speed of the LEDs. So you can see that the LEDs has increased the speed, and now I'm going to reduce the speed. And then, okay, I did not make a click. Okay, so now you can see that the speed has decreased. And now I will go further, and then you can see that the LEDs have slowed down. And also, we can quickly see the Wireshark trace if possible. I will need to open a terminal. Okay, and I need to, so just give me a moment. Yeah, my friend is going to help me here. Can you type the password? Yeah, you can say hi to Surya. Yeah, okay. So it runs on ENP. So this particular TK systems board has 4 ports, and I'm going to, so you can see that these are the pub sub packets, and I'm going to stop it. And you can see this is this is uh, the data that we are sending, and this particular one that you're able to see here is the each LED. So every time, okay, let me go down. You can see that that particular one is okay. It has other packets as well, so I just need to filter them out. Let me filter it. Okay, and this will be clear for you guys now. So okay, I just filtered out the wrong packet, but this particular PC does not have a filter for us, but at least you can see this VLAN ID that we are sending. So the critical application is sent at priority code point 3 and VLAN ID 2, and we are sending the data, pops up data packed as a UDP packet here. So this is what is happening right now. Yeah, so with this, I am completing my uh, webinar today, and you can see that connection of IO using PubSub over TSN to control. We saw what is time synchronization, running PubSub application, and we saw the Wireshark trace as well. And let me go to the next slide. Exercise 3, we saw what is 802.1 AS, we saw what is QBV, and we saw jitter analysis. So with this, I am ending my presentation, and thank you so much I understand that few people might also have a very basic understanding of OPCA. For them, I would suggest you to go back and refer one of the guides that I have shared already in my profile. So this particular guide, OPCA Resource for Beginners, would be very interesting place to start your OPCA journey, where I have shared both free and paid courses that you could start uh, by really great people. And and also we have one with B services as well. And this is my project page. I said I would do marketing, but still, this is what I do at B Services. So I manage this particular project, which is a government funded, German government funded project, which we work along with Offenburg University, and we are closing the project release, and we will be demonstrating this at SBS. So this is our eTSN SDK and this test suite that you saw. So let me connect back the cable back to the test suite so that we could see what is happening. This test suite also has other features like also we could see the time synchronization accuracy, round trip time accuracy. It has a lot of other features too, but today we just I just showed you these two applications to make sure that we are clear or not so confusing. And let me see if there are any questions, and you can start posting, and I would be happy to answer today. Yeah, please, anybody? Hello, Ram Gopal. Hello, Dennis. Hello.
Hello, hello.
Hello, Dennis. So,
Hi.
yeah, do you have any questions for me?
Me in particular? No, no. Just checking in here and listening about the
Mhm,
OPC UA. Yeah.
mhm. Great. Yeah, so you could see that the packets are coming back. It takes some time to synchronize, and then it would start to align because this particular, let me bring back the camera. So even the up to Pro should be synchronized with particular this TSN device with the nanosecond level accuracy, and then you could see that these graphs are getting in sync in a good pace. So did some okay. Hello, Jawahar, please go ahead.
Yeah, thank you, Melvin, for pronouncing my name correctly. Okay.
Huh?
I actually wanted to start with one quick request, okay?
Hmm?
Because the time here is like midnight 1:30. So
Okay. Uh-huh.
I would suggest like please have such sessions a bit earlier, so it will be very
Sure,
easy
sure.
for people in the other part of the world also to join.
Okay, that's great.
Okay.
I thought you had one
Uh,
request. I thought you would say stop doing webinars like this, but
okay.
but
Point number
thank you so
two.
much.
Okay.
Okay.
I've noticed like for one of the thing what you said is like the time series, in fact, like the scheduling perspective.
Mhm,
But when it comes to industrial applications point of view, right?
mhm.
Some of the elements or some of the like modules might be interested to send some more critical data which cannot wait until the token system is passed to them.
Yeah, yeah,
Say for example, you touched upon in between about like QoS, quality of service.
yeah,
So, have you implemented the QoS within this architecture of having OPC UA, then sending
yeah.
it all the way to like raw as well as using your
MQTT, right?
MQTT as well?
Yeah,
Yeah,
so we have done
that's
this
my first
already.
question. Yeah,
Yeah,
yeah.
so we have done this already, and I've not yet included it in this presentation. And so I've already showed a guide also, which is there in my profile. And I could also do this as next presentation. So we are having this exact demonstrator at SPS as well. So if somebody from your company or if you're available, so I understand that it's 1:30 for you. You should be somewhere far away from Germany. So if somebody is from there from your company, you could visit us, and then we could see like how we have integrated both together. And
Melvin,
maybe I could take this as a
uh,
topic for my next webinar as well.
Melvin, the time is 1:30 a.m., which means like midnight, not
Oh, okay.
1:30 p.m.
Yeah,
Okay?
yeah. But so
So
are you from US?
no, the other part of the world, Australia.
Okay. Australia.
Okay?
Okay.
Yeah,
Okay.
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 Uh, so the question on QoS, if you already have it in one of the blog posts, probably, like I will reach out to you
Yeah.
separately. Please to share
Sure.
it
Sure. Yeah. Yeah.
because we do, like use it for critical services, so which
Okay.
cannot actually leverage on the complete no round robin kind of stuff. And if there is a
Yeah.
mix of these things are already there, then it will be easy for us to know, like consider it as well.
Yeah. So
Thank you.
quickly, I want to touch one point. So this round robin system is working at 1 millisecond now. And also we can go down to 100 microseconds. And this is a 1 Gbps network. And also this can be scaled to 10 Gbps network. So hardly your packet will not need to wait even 1 microsecond on a real time purpose. So even it is so difficult for us to load the traffic. So we are creating some traffic generators, and these traffic generators are killing our systems because it needs to generate so much to load a 1 Gbps network. And also, if you say that I'm using only a 1 Mbps switch or a 10 Mbps network interface, so then there is another feature called as QBR and QBU, frame preemption, which will help you to do it. So as you said, we would please direct message me and we can discuss this in detail. So I quickly want to